What's up, y'all? So today we're going to be talking about the distributive property, both with monomials, binomials, and we'll sprinkle in some trinomials, okay? So distribution. All right, we are going to use this when we are multiplying, okay? An example of the distributive property, when we have that one term expression, the monomial, all right, multiplied by a two-term expression, a binomial. All right, we're going to treat this x, all right, like a mailman going to the different houses on the route. We got to drop something off there, and we got to drop something off there. We need to multiply for both of those. So x times x, all right, that would give us x squared, and then x times 3 would give us the 3x, and we would be adding those together. So that's what we would get when we distribute, all right, for that one term, okay? Let's distribute for the second. Let's say we got negative 2x. This is our second example. All right, example 1. We have a negative 2x, and we're multiplying that by x squared plus 2x minus 7, okay? Same thing, negative 2x is the mailman. It's going to every house along the route. It needs to stop there at the x squared. It needs to stop there at the 2x. And it needs to stop there at the negative 7, all right? Negative 2x times x squared, we're always going to add to the exponent when we are multiplying those variables. So this is x to the first, that's x to the second. 1 and 2 together will be x to the third, so that's negative 2x to the third. Negative 2x times positive 2x, all right, that's going to leave us with a negative 4x squared. Negative 2x times the negative 7, negative and negative makes it positive. That's going to be a positive 14x. And because we don't have any like terms, we're not going to be able to combine any of those, okay? So that's single term distribution. Taking this monomial and multiplying it by a binomial in this case, 2 terms, or a trinomial in this case, 3 terms, okay? Anything higher, we're just going to call a polynomial, all right? Now, let's actually look into double distribution, okay? And we are going to experience that, all right, when we have a binomial multiplied by another binomial, okay? So we have that x plus 3 multiplied by the x minus 4. So we're going to take that x first, and we're going to distribute just that term to the other 2 terms, okay? So the x is going to go to the x, and then that x is also going to go and travel all the way over there to the negative 4. Okay, the reasons why it's called double distribution is because we're going to distribute twice, all right? Once with the x, and then separately with this 3, all right? The 3 to the x, and then the 3 to the negative 4. Once we do that, all right, our multiplication would be x times x would be x squared. X times negative 4, which would be negative 4x. All right, and then in the other case with the 3, we have 3 times x. That'll be a positive 3x. All right, and then 3 times negative 4, which would be negative 12. Okay, we have to take into consideration that now we have like terms, so we need to add those like terms, those 2 right there, and we'll end up with x squared minus x, because negative 4 plus positive 3 gives us a negative 1, minus 12. And that will be our simplified answer. Okay, one more example of that. All right, and I'll just use one color this time. I just wanted to show you how the double distribution would work out. Okay, so we have x minus 2 multiplied by x plus 5. Okay, distribute the first term, distribute the second term. All right, we would get x squared, all right, and then x times 5 would be the 5x. Negative 2 times x would be negative 2x, and then negative 2 times 5 would be a negative 10. Combine our like terms, and we end up with x squared plus 3x minus 10. Okay, those are the two ways that we are going to work on distributing, all right, with a one-term expression to start, going into a multi-term expression, or a two-term expression going into a two- or three-term expression, okay? Couple of questions here at the end. Give those a good shot. We're going to have another video showing you a different technique with how to do this later on. Other than that, good job, and I will see you all next time. Peace out.